The, Phys- the Physics of Football by Zach Feinstone. In the world of sports, there's one constant, and that is physics. Physics is defined as the science that deals with matter, energy, motion, and force. There is no sport that exemplifies the laws of physics better than football. Newton's first law of motion. Newton's first law of motion is commonly stated as an object at rest stays and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. As it relates to football, a good example would be a field goal kick. First, the ball is at rest. When kicked, an unbalanced force puts the ball in motion. When the ball is at rest, its forces are balanced and acceleration and velocity are both zero. The ball will stay in motion until another force acts upon it. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object. In football, staying on the topic of the field goal kick, after the ball is kicked, it accelerates with a force that is directly proportional to the net force that the kicker's foot applies to it. This force can be calculated by the equation force equals mass times acceleration. Since the force acting on it has an acceleration, it is by law an unbalanced force. The amount of acceleration the ball experiences is inversely proportional to the mass of the ball. Therefore, in a rainy game, the ball would have more mass. Thus, the acceleration would be less when met with the same amount of force. Newton's third law of motion states that for every action, there is an equal and opposite reaction. An example of Newton's third law in football would be a receiver catching a pass. When a receiver catches a pass, his hands exert a force equal to the force of the ball, but in an opposite direction. This equal but opposite force stops the ball and brings the ball to rest once again. Bringing it back to the law of the first motion, which states that an object in motion will stay in motion until acted upon by an unbalanced force, this force being the receiver's hands. Collisions in football are a staple of the game. The collisions that occur in football can be explained through physics as well. There are two types of collisions, elastic and inelastic. In elastic collisions, both kinetic energy and momentum are conserved. In inelastic collisions, only momentum is conserved while kinetic energy is lost to other forms of energy. For football, we will say that a tackle is an elastic collision and a block is an inelastic collision, although these are not perfect examples. When a player tackles the ball carrier, they do not remain in contact after the collision, making it an elastic collision. When a player does so, he exerts a force over a period of time on the running back. This is referred to as the impulse, or change in momentum. In order for the running back to successfully tackle or stop the ball carrier, he must exert an impulse equal to or greater than the momentum of the running back. Since force is multiplied by time in this equation, an increased time of contact can stop a running back of the same momentum with less force. Since this is an elastic collision, the conservation of momentum equation looks like this. Mass of 1 times velocity of 1 plus mass of 2 times velocity of 2 equals the mass of 1 changed times the velocity of 1 changed after contact plus the mass of 2 changed after contact times the velocity of 2 changed after contact. Notice how there are two objects before and after the collision, and the kinetic energy equation can be applied and seen that it equals the same on both sides of the equation. Blocking in football simulates an inelastic collision, or the closest thing to it. Neither the tackling example or the blocking example are perfectly elastic and inelastic, respectively, but they serve good enough visuals. When blocking, two players collide and stick together for the remainder of the play, which is the textbook definition of an inelastic collision. When two objects collide and stick together, this is what is called an inelastic collision. This results in the conservation of momentum equation looking similar to the mass of 1 times the velocity of 1 plus the mass of 2 times the velocity of 2 equals the mass of 1 plus the mass of 2, all multiplied by the final velocity of the now stuck together objects. Notice how the product of the collision yields only one object. When the kinetic energy equation is plugged in, it will not equal the same on both sides. Momentum, though, is still conserved in this collision due to the law of conservation of momentum. Passing is another important part of the football game. Projectile motion is classified as an object that only gravity is acting upon. The angle and velocity that a football is thrown determines the horizontal and vertical displacement of the football. When a player punts the ball, vertical displacement and hang time are just as important as horizontal displacement. When the quarterback passes the ball, distance or horizontal displacement are the main concern. In order for a quarterback to increase or decrease his horizontal displacement, he must adjust his angle and velocity accordingly. Vertical displacement can be found by the equation y equals initial velocity of y times t plus 1/2 the acceleration of y times time squared if launched from an angle, or 1/2 gravity times time squared if launched at a perfectly horizontal. Horizontal displacement can be determined by x equals initial velocity of x times time plus 1/2 acceleration of x times time squared if launched from an angle, or initial velocity times time if launched horizontally. Horizontal velocity is constant throughout when projected at a perfectly horizontal angle. Vertical velocity is the product of gravity and time when thrown horizontally. More realistically, quarterbacks will throw the football at least at some sort of angle. As physicists, we know that horizontal displacement is maximum at 45 degrees given a constant component of velocity. When the football is thrown at an angle, final velocity can be found using the equation velocity of x equals initial velocity of x, final velocity of x equals initial velocity of x plus acceleration times time. Final vertical velocity can be found by the vertical velocity of the final velocity of y equals the initial velocity of y plus acceleration times time. To find the initial vertical component of velocity, we will need to use sine, because the initial velocity gives us the hypotenuse, and since we know the hypotenuse, we need to find the opposite side of the right triangle to find the vertical component, which is why we use sine. The cosine of the angle tells us the initial horizontal velocity of the football when initial velocity is given. Football is filled with physics lessons and examples. Every single snap, down, and second of the game can be clarified further through the understanding of physics. Physics principles can be applied to the game in a variety of different ways. Physics and sports have such a dynamic relationship, one simply cannot be without the other. I hope that my PowerPoint has highlighted and given insight to the underlying components of the game of football as they relate to physics. Thank you for listening today, and I hope that I have given you a new way to look at one of my favorite sports.